Should I stay or should I go now? Using AI to determine pedestrian intent. I'm Tonya Hall for ZDNet and Tech Republic, and joining me is Dr. Sam Anthony, co-founder and chief technology officer at Perceptive Automata. Welcome, Dr. Anthony.
Thanks for having me.
So, what does Perceptive Automata do, and what motivated you to found the company?
What we're building is a module for autonomous vehicles and for advanced driver assist systems that lets them see the world, and especially people in the world, the way that people do. It can look at a pedestrian or a cyclist or a motorist and understand their state of mind. This is incredibly important for these vehicles to get them on the road because we as humans are effortlessly good at understanding other humans. And if these vehicles don't have this, I walk a lot. I walk my kids to school every day. And when I'm walking to school, I think about what's going to happen if there's a vehicle there that's an automated vehicle that doesn't know that I want to cross the road, that doesn't know, that I'm waiting to see what happens before I cross the road. So having this ability to see the world like humans do is vital for these vehicles being safe and smooth and good citizens of the road in general.
So, up to this point, what sensors and data do autonomous vehicles use to help them make these navigation decisions?
They have a really rich set of sensors, right? They have LiDARs that can see in the dark to some degree. They have stereo cameras. They have radars for short range detection. I think one thing that people don't necessarily realize is how different the information about the world that these vehicles get is from the information that we use. So for instance, a LiDAR can see in the dark, but all it's going to tell you is, oh, well, these three dots over here correspond with a human being. They don't tell you anything like, oh, that person's waiting for a bus, or, oh, watch out, that's a little kid, or oh, I think that person might be drunk, you should be extra wary. They are giving you a sort of very limited sense of this is what's here, this is where it is, this is how fast it's moving, but what they don't really give you is the understanding piece.
What role does silent communication play in the interplay between human drivers and other humans sharing the road space?
It's completely fundamental. The thing we did when we started this company is we went out, not with a car, just kind of walking around intersections and recording intersections with a GoPro. I recorded one video, and in 30 seconds of this video, there were something like 45 instances where a human looked at another human and made a judgment about what was in their head, said, oh, I know what that person wants, and I know how to respond to that. In urban areas, when you have a mixed environment with cars and pedestrians and cyclists, it happens constantly. On a highway, it happens all the time as well. It's a huge part of driving, and it's something that we don't even necessarily notice because we're so good at it.
You mentioned smiling. You also mentioned a drunk person and being able to pick up on cues. So what are some of the cues you measure to determine intent, and what technology accomplishes that for you?
Yeah, so the way that our method works, we don't try to make a list of the features that matter, because if we tried to make that list, we would miss things. Instead, what we do, we use the techniques of behavioral science, of neuroscience, of experimental psychology to capture as richly as we possibly can all of the features, just down to a pixel level, that people use to make these judgments from our training samples. And then when we train our models, what our models do is they kind of automatically figure out, well, it turns out for this one, this person's carrying a bag, say, and they tensed up a little bit with their bag, and that means they're probably going to start walking soon. So, if you had asked me before I started this process, is it important to look at the way somebody's holding their bag to know if they're going to cross the street? I'd be like, what? I don't think I do that. But it turns out that we as humans do that. And our model was able to pick up on that without us ever explicitly modeling.
How do you go about building the data set underlying your AI?
Oh, it's such a pain. So that's really where our differentiation comes, right? So the normal way that people train models, say you want to train a model to identify pedestrians, you get 100,000 samples that have pedestrians in them, You label those with a 1, you get 100,000 that don't have a pedestrian. You label those with a 0, you feed that to a deep network, you're good. For us, every fraction of a second in our training data that's relevant, so every fraction of a second where there's a pedestrian or cyclist or other motorist, we take that fraction of a second and we manipulate it to make versions of it where people are going to rely on different information. We take those manipulated versions, we show them to large sets of people, we ask those people different sorts of questions to elicit not just, the answer, yes, this person is going to cross, or no, but implicit information about how they're making the decision and how they're thinking about it. Because what we want to get at is, we're going to get hundreds of pieces of information about this sample, and what those should all kind of point to is the underlying implicit judgment of what's in the person's head.
What technological hurdles did you have to overcome to design a system to work in 4 seasons of driving environments? You've got people bundled up in heavy winter clothing, or is that more difficult to interpret than maybe those, wearing shorts in the summer on a nice day?
There are certain kinds of weather that are really hard. So heavy snow, it turns out that people, if they're wearing kind of hoods and they're bundled up, they're not paying attention to anything. They're not giving off any social signals. What I guess is the advantage of that from the perspective of a self-driving car is the solution is you should go extremely slowly. So even the best functioning self-driving car, my answer for that when it's a blizzard is, well, just don't go very fast. What's really interesting for us is that we also have to account for cultural differences. So for instance, somebody who grew up driving on the right here in Boston is going to have a very different sense of what social signals mean than somebody who grew up driving on the left in India or something like that. So understanding how these kinds of judgments are common across cultures and how they differ across cultures is something that we pay a lot of attention to and have had to develop methods to account for. And I think we are in a very good place with it now, but it's kind of an aspect of this that doesn't come up in normal approaches to computer vision, in kind of standard approaches to computer vision.
What about age of humans? I mean, does that play a part? You've got a 2-year-old that might be randomly, unsuspectingly run out in the road to chase a ball, or you might have an elderly person who's trying to cross the road with a cane and might fall. How does age play a part?
It comes out of what our models do implicitly. So one of the things that our system does is it doesn't just tell you this person wants to cross the street, this person doesn't, but it tells you something about how certain that is, and not just how certain that is for our model, but how certain that would be for people. So if you think about seeing a kid on the street, if I'm driving and I see a kid on the road, then I immediately think, ooh, I need to be careful because who knows what that kid will do. In that situation, there's a lot more ambiguity. I can't, as a human, make as reliable a judgment about what's going to happen next, and so I drive accordingly. So that sense of the real ambiguity is something that our model outputs and something that then our customers can use in planning for these vehicles.
Okay, so vehicles now recognize a pedestrian's intent, but communication is two-way, right? So how do you communicate the vehicle's intent once you make a decision on what you're going to do about the pedestrian?
Absolutely. That's something that I think people are working on, and there are really cool solutions. The way that we hope to enable that, the way that we think about that, communication is absolutely bidirectional, but the sort of the grammar that a car has, the number of signals that a car has available to communicate things are pretty restricted. So if you understand the world well enough, if you understand what someone wants well enough, then the sort of process of, okay, well, I can say sort of 3 things. I can slow down, I can be at the same speed, I can flash my lights. That sort of limited grammar is, you can deploy it pretty easily once you have a rich understanding of the world.
Dr. Sam Anthony, co-founder and chief technology officer of Perceptive Automata. Welcome, and thanks again for joining us. If somebody wants to find you, maybe they want to find out more about your company or maybe connect with you personally, how can they do that?
I would encourage them to look me up on LinkedIn. I'm on there as Sam Anthony.
All right, sounds good. And if you guys want to find more of my interviews, you can do that right here on ZDNet or Tech Republic, or go to my website, tonyahall.net. Thanks for watching.